Welcome back to the Explainer. You know, the way our bodies manage fluids and electrolytes, it's one of the most fundamental, high-stakes balancing acts happening inside us every single second. This whole topic is so crucial, we're actually splitting it into two parts. So today, in part one, we're going to tackle the big one, the body's essential balancing act of fluid volume. Okay, so here's our game plan. We'll start by exploring our body's internal ocean. Then we'll meet the key chemical players, the electrolytes, and understand the control system that keeps it all in balance. And finally, we'll dive into what happens when that system fails, leading to a body that's either running on empty or totally flooded. All right, first things first, let's talk about the body's internal ocean. So it's a wild fact, but you're basically a walking, talking bag of water, about 60% water to be exact. But this isn't just simple H2O. This internal ocean is the medium for transporting nutrients. It's the venue for almost every chemical reaction in our cells, and it helps keep our body temperature right where it needs to be. It is quite literally the stage for everything. But here's the thing. This 60% isn't just one big swimming pool. No, the body is much smarter than that. It carefully divides all this fluid into different compartments to keep the whole system running perfectly. So the vast majority of our fluid, we're talking 2/3 of it, is locked safely away inside our trillions of cells. We call this the intracellular fluid, or ICF. It's very stable. The other third, that's the extracellular fluid, or ECF. This is all the fluid outside the cells, and it includes the plasma in our blood. This ECF is what we're really zeroing in on today, because as you can see, it's much more prone to being lost. Okay, so how does water move between these spots? It all comes down to a simple but incredibly powerful rule called osmosis. And it's this: water always follows solutes. Think of solutes like tiny particles of salt. If you have more salt on one side of a barrier, water is going to rush across to try and dilute it. It's all about finding balance. So, since we know water follows solutes, it's probably a good time to meet the most important solutes in this whole process, the electrolytes. Now, these aren't just passive little particles floating around. Electrolytes are active chemicals that carry an electrical charge. You can literally think of them as the tiny, charged wires that run our entire biological machine. They make our nerves fire, they make our muscles contract, and they tell water exactly where it needs to go. Now for today's explainer on fluid volume, the absolute star of the show is sodium. Notice how it's the main player out in the extracellular fluid. You know, the fluid we just said is prone to loss. Well, that's no coincidence. The rule is simple and powerful, and if you remember one thing, make it this: wherever sodium goes, water follows. Potassium, on the other hand, hangs out mostly inside the cells, and that's a whole other critical story for part two. So with all these fluids and charged particles zipping around, how on earth does the body manage it all? Well, it has this incredibly smart, fully automated engine designed to maintain perfect balance. This whole process is called homeostasis. It's the biological principle of keeping everything just right, not too much, not too little. And when it comes to body fluids, the master regulators of this whole operation are the kidneys. They are constantly filtering our blood, making executive decisions about what to keep and what to get rid of to maintain that perfect balance. A huge part of this is the RAS. Think of it as the body's emergency 911 call. When your kidneys sense that blood pressure is dipping too low, they kick off this whole chain reaction. The end result is a couple of hormones that do two key things. They constrict blood vessels to bump up the pressure, and most importantly, they tell the kidneys to hang on to sodium and water to bring your fluid volume right back up. But what happens when this system just can't keep up and your fluid volume plummets? Well, that dangerous condition is called hypovolemia. Okay, it's really important to get this straight. This is not the same as simple dehydration, which is mainly a loss of water. In hypovolemia, you're losing both water and critical electrolytes, like sodium, in roughly the same proportions. It's a true deficit in the volume of your extracellular fluid. And the causes? They're often exactly what you guess. Any situation where you're losing more fluid and electrolytes than you're taking in. We're talking severe vomiting or diarrhea, hemorrhage, or even something called third spacing, which is a unique situation where fluid actually shifts out of your blood vessels into a space where it's no longer useful, like what happens with severe burns. When this happens, the body sends out some pretty clear warning signals. The heart starts beating faster, that's tachycardia, trying to compensate for the low volume. Blood pressure drops, your skin loses its elasticity, it's what we call tenting, and you lose weight, because remember, 1 liter of fluid weighs about 1 kilogram.
Okay, let's flip the coin and look at the opposite problem. What happens when the body gets overwhelmed with too much fluid? That's called hypervolemia.
So, just like its counterpart, hypervolemia involves both water and electrolytes. It's an expansion of that extracellular fluid, and it's caused by the body abnormally holding on to both sodium and water. The system has failed. It's completely flooded. This condition is often a secondary problem, usually caused by failures in the major organs that regulate fluid. Think about it. In heart failure, the heart can't pump effectively, so fluid backs up. In kidney dysfunction, the kidneys simply can't get rid of the excess salt and water like they're supposed to. And the signs of being flooded are just as clear. All that excess fluid starts leaking out into the tissues, causing edema or swelling. The veins in the neck bulge out. The fluid can even back up into the lungs, which makes a crackling sound. And you'll see rapid weight gain, high blood pressure, and a really strong bounding pulse. So when you put them side by side, you really see the crucial differences. In hypovolemia, everything is down. Low pressure, a fast but weak pulse. The blood itself actually becomes more concentrated, so lab values like hematocrit, which is the percentage of red blood cells, go up. In hypervolemia, it's the total opposite. The blood gets diluted by all that excess fluid, so your hematocrit goes down. And this really captures the essence of it all, doesn't it? Fluid volume is the foundation, and when it's not right, whether it's too high or too low, nothing else in the body can function correctly. Understanding this delicate balance is absolutely the first and most important step to mastering this topic. And that brings us to the end of part 1. We've really nailed down fluid volume. Next time, in part 2, we're moving beyond just the volume to decode the electrolytes themselves. Sodium, potassium, calcium. We're going to explore the critical electrical imbalances that can cause seizures, stop muscles from working, and even stop the heart. It's a discussion you are not going to want to miss.